Hello students, in this video we'll see an example of the binomial distribution. Let's suppose you will receive a personal letter in the mail with probability .1 each month. And we will assume that each month is independent. Let's find the probability that you receive at least 4 personal letters this year. So in other words, what we want is we can let n be the number of personal letters received each year. We'd like to find the probability that n is at least 4. So the question becomes, what's the distribution of n? So we can note n is the result of 12 independent trials. And so that tells me that n is binomial with the number of trials n being 12 and the probability of success of one of those trials being 0.1. So the probability that we want, the probability that n is bigger than or equal to 4, will be 1 minus the probability that n equals 0 plus the probability that n equals 1 plus the probability that n equals 2 plus the probability that n equals 3. So we can compute each of these probabilities since it's binomial. This will be 1 minus the probability that n is equal to 0 is from 12, choose 0, and then I will have 0.1 to the 0 power, and then 0.9, the successive failure, 12. That means I'll have 12 months of failure. Then we'll have plus, from 12, choose 1. I'll have 1 success of getting a personal letter, and then I'll have 11 failures. Then from 12, choose 2. 0.1 squared, I'll have 2 successes and 10 failures. And finally, from 12, choose 3, I will have 3 successes and 9 failures. And we can plug this into a calculator and figure out what it is. So it's important to note that since we were given that each probability was 0.1 and the months were independent, I have 12 independent trials. When you have a certain number of independent trials and you want to count the total number of successes of those trials, the result will be a binomial distribution. The rest of the problem simply involves plugging in, computing these binomial coefficients, and plugging into a calculator and checking. Thank you very much.